Multiplying binomials using the process commonly referred to as FOIL. FOIL is just an acronym that stands for the process first, outer, inner, last. It's just an easy way to help us remember an order by which we can distribute one binomial through another. You don't have to do it through this order. It's just an easy way to get through the process systematically and easily. I'm going to show you how to do it. If you want to take notes using one of my note sheets, this lesson correlates with the note sheet titled Working with FOIL. Let's say we have the two binomials x plus 2 times x minus 6. First, let's distribute the first term. So we're going to take the two first terms that are in our binomials, and that is what is connected by this first arrow. So let's say these are our first terms. Then we're going to multiply our outer. The outer terms are our two terms on the outside of our parentheses. Then we're going to multiply our inner terms. They are the two terms that are on the innermost part of the parentheses. And finally, we would multiply the last terms. Now, let's go ahead and apply this process. Let's use the example x plus 5 times x plus 10. If we want to multiply the two first terms in our parentheses, we would multiply x times x. And that would give us x squared. If we multiply the two outer terms, we would multiply 10 times x, and that would give us 10x. If we multiply the two inner terms, we would multiply 5 times x, and that would give us 5x. And finally, the two last terms would be 5 times 10, and that gives us 50. Now all that's left to do is combine like terms. The only like terms we're ever going to have when we multiply binomials are our two inner terms. In this case, they're both positive, so we combine and we have a positive 15x. Now just write your final result, and you have x squared plus 15x plus 50. And you've multiplied your first pair of binomials. Let's try another one. X plus 2 times x minus 6. The first terms, again, x times x gives you x squared. Your outer terms, x times a negative 6. Always remember to watch your signs. Gives you a negative 6x. Your inner terms, 2 times x. That gives you a positive 2x. If it helps, write your sign. And your last terms, positive 2 times a negative 6. Remember, watch your signs. Negative 12. Now combine your two middle terms. A negative 6 and a positive 2 gives me a negative 4x. Now write your final result. X squared minus 4x minus 12. Let's try another one. I've already completed this one for you, but let's take a look. 3x plus 5 times x minus 4. When we multiplied the first two terms, 3x times x, we got 3x squared. When we multiplied 3x times minus 4, we got negative 12x. 5 times x gave us 5x, and 5 times negative 4 gave us negative 20. Combine the middle terms to get negative 7x. Put it all together to get your final result. Let's look at one more. 2x minus 3 times 4x minus 5. 2x times 4x gives us 8x squared. 2x times negative 5 gives you negative 10x. Negative 3 times 4x gives you negative 12x. And negative 3 times negative 5 gives you positive 15. Combine your like terms in the middle and get negative 22x. Put it all together for your final result, and you're done. Pay close attention to the next 4 examples. They're special magic binomial products because they have disappearing parts. Let's multiply x plus 9 times x minus 9 and see what happens. X times x gives us x squared. I'm seeing a pattern here with these first 2 terms. X times negative 9 gives me negative 9x. 9 times x gives me positive 9x. Positive 9 times negative 9 gives me negative 81. Combine my 2 middle terms, and what do I get? Negative 9x and positive 9x. I get 0x. So x squared plus 0x minus 81. Well, I don't write 0x. So that term, it just goes away. I'm left with x squared minus 81. So there was my disappearing term. This is a special kind of binomial. This is called the difference of 2 squares. And the reason it's the difference of 2 squares is because I'm subtracting 2 perfect squares. You're going to need to know that later when you learn how to factor. But it never hurts to learn a little something extra as you go along. And these are perfect squares because they're made by multiplying the same number times itself. You may remember 9 times 9 equals 81. And x times x equals x squared. So just file that away for later in your brain. Let's move on to another one. Okay, 3a times 3a. 9a squared. 3a times b. 3ab. Negative b times 3a, negative 3ab. And negative b times positive b is a negative b squared. Again, I have opposites here in the middle, so I have 0ab. It's going to disappear in the middle again. So I have 9a squared minus b squared. Again, the difference of 2 squares. So whenever you see 2 binomials like this, where they're the same thing with opposite signs, then it's the difference of 2 squares. 3a minus b, 3a plus b, then this is going to happen. The middle term's going to go away. Here's another one like that. X plus 6, x minus 6. You can know right away that the middle term is going to cancel out. X times x gives us x squared. X minus 6 is minus 6x. 6 times x is positive 6x. And positive 6 times negative 6 is negative 36. The middle terms cancel out, and we're left with x squared minus 36. Again, 3t times 3t, 9t squared. 3t minus 8, negative 24t. 8 times 3t, positive 24t. And 8 times negative 8 is a negative 64. Your middle terms cancel out again and become 0. And you're left with the difference of two perfect squares. You try. Pause the video and see how you do on these three problems. Well, how did you do? Here are the solutions. In the first one, we need to distribute m times m times minus 8, 4 times m, and 4 times minus 8. You should have gotten m squared minus 4m minus 32. In the second one, distribute 2x times x, 2x times minus 2, 4 times x, and 4 times minus 2. Your 4x's cancel out and you're left with 2x squared minus 8. In the last one, you needed to rewrite your binomial out so that you were squaring it, in other words multiplying it times itself, and then continue with FOIL, and you end up with x squared minus 10x plus 25. I hope this lesson gave you some insights on FOIL and help you understand it just a little bit better. With practice, you'll be able to complete multiplication of binomials with no trouble at all.